ellipse. What do we understand by an ellipse? We've been practicing with them from the beginning of every class, doing a little bit of warm-up, right? So an ellipse is basically a circle in perspective. So if this is my front view, nothing's happening. All right, I'm giving another try to this. If it doesn't work, we'll do it in digital format. My apologies. All right, hold on. So I'll explain it with the software here. We're talking about the circle, the ellipse being a circle in perspective. So what does that mean? It means that if I am looking at that circle from, let's say, a front view, I'm going to see a normal circle, right, over there. If I, however, like this would be, let's imagine this is a plane, right? And I see a square, then I see a circle. I know I'm touching this 4 points, right? If I join this, this goes to the middle. So if I were to take this ellipse and send it to a plane in perspective, I'm gonna kind of meet the same points. I'm gonna be touching, if I find this mid-ground, I'm gonna be touching the front, the top, the bottom, and then the edges, right? So my ellipse, being a circle in perspective, is going to look like something like that, okay? Now, the ellipse has an anatomy, which means there are parts that we can identify. When we practice in our warm-up every day, we would practice doing ellipses like that, and we'll say that they have a minor axis, and we say that they'll have a major axis, right? So these two are 90 degrees from each other. And one of the things that we can do to say if my ellipse is correct or not is that it needs to be symmetrical in these two sides and symmetrical in these two sides, right? Now, when we talk about perspective, the minor axis is going to be really useful, and the major axis, we kind of could pretty much ignore it forever. It's not going to be useful to us, and it's going to get us confused. And I'll show you why. Because usually when we're in our class, we tend to do this division and think that this is my minor axis and this is my major axis, and that's not true. All right, so this is crucial for you guys. My minor axis in perspective would always be perpendicular to the plane that it's on, which means it's going to my perspective, meaning that somewhere down that side there is a vanishing point, right? So let's try this again. If I have a plane in space, I know that I'm going to have a vanishing point, going towards that direction, right? If I use these 2 points, that's going to be going to my left vanishing point. If I made this plane a box, then I would have probably another vanishing point somewhere in the distance on that side, right? Which means that for my ellipse, I can find my center, so I can find points that I'll be touching. This point also has to go to the vanishing point, right? This line then becomes my minor axis, which means that I need to touch those points. For example, real quick, is that ellipse correct or incorrect? That's incorrect. It looks closed, and we're going to be showing that. But if we talk about an ellipse and its minor axis, we're talking about that, right? And if you see this, this is a little bit off from that, right? This is a little bit like that. So that's how we know that ellipse in that plane is wrong. So if I were to change my color here to find out the good one, again, this is going to be going to my vanishing point. So my ellipse needs to be 90 degrees from that. So it's a little bit off. I'm still touching this, this, and that. But I have this half to be symmetrical to that half. All right? So it feels a little bit confusing, but what happens if I remove my planes? If I remove my planes and I just say that, okay, that's my vanishing point, it's going somewhere there, and I start adding ellipses to this, I have a cylinder, right? Now, why is the box important? Why are the planes important? First of all, because there is no easy way to figure out the degree of that ellipse. Do we know what a degree of an ellipse is? Right? If we talk about that plane in perspective, and I have a plane that I see a lot from the front, in this case, my ellipse is going to be a little bit fatter. Right? It's almost a circle. Different than the ellipse that would live in this plane, right? So we're talking about degrees of ellipses. This would be a larger degree than this. A circle is a 90-degree ellipse because we see it exactly from the front, right? If I start tilting that plane, then I start seeing 60 degrees, 45 degrees, 30 degrees, and so on. So the way to determine that I am doing the correct degree of the ellipse is precisely by making sure that I'm touching those points, right? The top and the halves. So what I would like you to do as a first exercise is precisely to go and get some planes in perspective, define the direction of the vanishing point so that that is your minor axis, and then try and get that ellipse. Tips for that: draw a largish square. Let's say that probably you'll fit a minimum of 5 of this in your page. Sorry, a maximum. So that you have enough control with your shoulder to do those ellipses. All right? But remember, when you're doing this, remember this example that I just did. Okay? You want this to be symmetrical to that. All right? If the line that is going to the vanishing point means that your ellipse is like this, that's incorrect. All right? If that's your line for the vanishing point and your ellipse is like that, that's incorrect. You need to make sure that no matter how that box is, this side and that side need to be symmetrical. You need to be touching the halves of your box. All right, so let's do this for 10 to 15 minutes, and then I'll call you guys back to the room to see the next step of the demo. Let's go. This class right now, but on your own time you can do it. there's this magic tool called an ellipse template. And what it does, and I think that the reason I'm showing you, because I don't want this to become a crutch for you, but you'll notice when I rotate this thing, how that works, right? That minor axis moves. So let's say that I have a vanishing point here. That would mean that wherever I put my ellipse, that minor axis needs to go to the vanishing point. So I can draw that, right? Let me draw first a point. Oops. So this is the center of my ellipse. Notice how that has to match there. So then if I do another, let me just mark that axis, right? So we have that. Because this would need to have right? So that's the thing. If I actually, let's go backwards. If I added the plane after that, I can have any direction that I want. For example, let's say that that goes into my vanishing point, right? So I'm still touching the top, the bottom, and both sides. But if you check, I can do my shape here, and that minor axis is not going to line up with any of them, right? All right. I was just telling everybody that in your How to Draw book, pages was 71 to 73, you can find these explanations again of what we're seeing today. So in our assignment sheet, we are currently about to start this one, right? So now we're going to transform our ellipses into cylinders. So you're going to have a template that looks like this. Template that looks like that, and what you will have to do is, using your pen, you're going to find the center of these planes, right? And now with your practice of joining dot to dot, you'll find that axis for that cylinder, right? After that, you'll determine where I'm going to need to touch. But if you see, it's different from my actual lines. If you want to use a different color so that you can see the two layers, go ahead. But it's important to know that this and not that is my minor axis. right? So I can probably leave it there. And then you'll rotate your paper to whatever you're more comfortable sketching. I'm going to drop your ellipse. It's a little bit crooked actually in this case, so that it's that guy. Right, trying to get that symmetry. And once you're done, all you need to do is touch the tangents and probably add a little bit of line weight. So you'll remember this from foundations. You did an exercise where you had to make that line kind of switch line weights. We kind of want to do that as well. Okay, so we want the edge. If you have, unless you want to darken the edge, remember your wrist is a natural like kind of compass that you can do an arc. So you can play with that ability. Because we want to figure out what part of our ellipse is looking towards the shadow and which one isn't. Now, how would I cast a shadow of this cylinder? Do we have any idea? Okay. So, light direction, we're just going to touch tangent to any point that I want. For example, let me change color so you can see that. That's my light direction. And then same thing about my shadow direction. So, it's going to find it there. It's going to find it there. And then we're going to do the same thing. Actually, let me go back a little bit. Okay, so from that point, we also want to know, depending from my shadow direction, where that's going. So if it's there, would have the same on the other side, right? Projecting. So I can connect these two guys. And then from then on, over here and over here. Alright, so find where the tangent is, find where the other tangent is. This is going to be kind of like an arc, and then the other two are your kind of like straight lines there. Yes?
And that's tangent to the light direction?
The point that you find here, you will get that projection from a tangent. So if I want my line direction to be this, then my point would be there. Okay? So let's try it again with, for example, my vertical cylinder here. Alright, so same thing. Find your points. Vertical's a little bit easier because my vanishing point is not, my axis is actually not going to the vanishing point, just going down. Right? So we need to make those 2 points join. Right? So my axis would be something like that. Right? Something going down as well. Finding where they will hit each other. And this one you need to get perfect because you did this exercise in foundations, right? And you did like a 30,000 ellipses with varying degrees. So this one you should get right. Right, so what's my minor axis? This guy here. So that's my ellipse. And what about this one? It's still that line. And then join those tangents. Okay. A little bit off. Now, vanishing, cast shadow for this. Shadow direction. Light direction. So if I'm getting this from this point, I can bring this to the top. And then this one's easy because if I have this, I'll just draw it here at the bottom. Cast shadow. Cool. So for the next exercise, I want everybody to come over and get one of these sketches. You can pass them around. There should be enough for both sections. If there aren't, just let me know. Okay, want to pass it around? Yes, use them as underlays because we're going to do more exercises with that. Okay, any questions here? No? All right. All right, so for the next thing, you're going to use the same boxes to create a series of shapes that we're going to accomplish by moving the size of those ellipses. You can do organic shapes or you can do more geometric shapes, but it's just super fun. You'll see. So for example, let's say that I have this vertical cylinder and I just show you how to sorry. Can you guys help me? Just turn it on, power. My apologies to you guys. So now that you can see the demo. So I'm just quickly going to find the axis of this box. Alright, so I have that. It's probably there. So if I just do a cylinder, so an ellipse that fits there, and an ellipse that fits there, and I connect those, I'm going to just have a traditional cylinder like the one that you just created. However, I can use this and change the size of this ellipse. I'm going to do the same kind of ellipse, just I'm going to move it towards kind of like this direction. Maybe I do another one there. Maybe I do another one there. And another one there. So I'm offsetting my ellipses, and if I start by connecting those tangents, right, I'm going to generate now this is kind of an alignment. I'm going to generate some different shapes, right? So I can do that. I can join them by using straight lines to have like surfaces, like kind of becomes cones and cylinders, or I could connect them with a curve, which will give me a different type of shape, right, of a different quality. So this becomes a really useful tool to design all sorts of things that are based on rotation or revolve, right? So let's try it on this one. Trying to be a little bit gentler with that. So that's one. So I have my axis, and then I can start, okay, I can do a large cylinder here. Then on that same axis, I do a smaller one here. And actually, that's a little bit off, because this should be there, right? Then I can have another one, another one, another one, right? And again, I can just like join all those tangents to create that form. And then I can add my line weight to this to understand what's going on. Now, what if I want to add part lines to this? I'm going to need to do what is called a XYZ drawing here. And what I'm going to do is I'm going to start selecting, I know, this line that's going to be touching, let's say the same lines of my sketches. I'm going to do a different color so you can see. Not there could be. It's just it's like a cross contour, yeah, like a section line. That's going to help me know what this is doing, right? So I'm describing my surface with that, and I can then do another one here. I could do another one there, kind of like describe whatever my surface is doing. But then I know and understand the surface of my cylinder, right? Yes, I could make one of those a part line so that I can say that this is now a different material than the other one, and project to the other side. But the main thing is that if I wanted to, let's say, have this, and then, I don't know, create this crazy shape here, I have enough information that if I want to change this shape, I can create, let's say, a shape that would, instead of being smooth like this, it could come up, down, and to the other side. So I'm going to do it here real quick. So that's my axis. Let's say that this is my design. If I know that this is the way my surface behaves, and I want to then decide I'm going to draw like this crazy part line there, that's like a sticker that goes on my surface, I could decide with this, okay, maybe instead of this being like a smooth line, I can bring it down and I can bring it up. This will do the same, and then I can give that cut here. So I just made this one a little bit thicker. Let me draw my final lines in black. so that this drawing that I did here just represented a change of surface, right? So now I can see with that cross contour line, that section line, that there is a difference between what is going on there, right? And with these lines, that's what I use to help me understand how this surface is changing, right? So I can continue working and creating these shapes, and if I want to, I can add elements and I can change it. Let me just turn all of this off and show you this. Oops. So I can draw my axis, right? And then I can start drawing my ellipses on that axis for whatever I want to design. So that perhaps I get a flashlight that looks like that. And let's say that in my design I want to put a button on it. So the way to know how that button could go is I'll find one of those lines. I could do a couple of ellipses there and decide that my button then will go on that space. But I want it to be smooth. I want, if I run my fingers, I want to feel that button raise. But that button raise up. Right? So perhaps currently that line is just like smooth like this. What if I bring that up a little bit? And then I bring those lines up again as well. So see how that line changed? And if I had like another line here in the middle, it would have to go up here, there, and then go back and continue working with that. So think of it about it as a coordinate system. If I wanted to do another one of these guys, let's say that I do it here on the side, I could still use that to create that, then change my line work and create that. So I can play with the form by using those lines. So right now we're doing offsetting of ellipses, and you can create revolve shapes. The next activity will be to do shapes like this with the same template that I created. You'll notice that in that case the box was a little bit small. Don't worry, continue going up. Just remember the trick. My ellipse is perpendicular to my minor axis. So if I do that, all my ellipses are going to be there. If I do that, that's incorrect. However, if I wanted to create a snake, and I can create a line like that, as long as I start keeping that ellipse 90 degrees to where that is, I could create a snake. Snake. All right. Yes, over there. Good question. All right, that's a good question. So what happens if you want to have something that is, let's say, cylindrical, but in your side view it looks like, I don't know, like this. Let's say that's my lamp, right? That will mean that I will have to create a cylinder, and perhaps once I decide that this is the shape that they're going to have, then I'm going to have to switch it, right? But then look at the difference, that this one is matching, this one is working with my ellipse, this one isn't, but it's parallel to my plane. So if this was my plane in perspective, right, my minor axis is still parallel to how that plane goes. So imagine that you put a stick on that, like if I were to continue this as an ellipse in a different direction, so that I could do a shape that looked like that, it would still go through the minor axis. Cool? All right, so let's go back and continue practicing with that. And Brian should be in your classroom in a minute. Now, right?